So these orbital picture answers can be difficult to see in 2 dimensions. And so here I've provided a 3-dimensional model to help see the answer if you're having trouble. The answer indicates that the hydrogens on either end of the molecule are not coplanar, meaning they're not in the same plane. And here I've built a model that shows the hydrogens situated in a coplanar arrangement, meaning all in the same plane. Okay? So I've taken a fly swatter and I've smacked this molecule. It is perfectly flat, planar. That's opposed to the situation that looks like this. So here I've rotated about the bonds so that the hydrogens on this end are not coplanar with respect to the hydrogens on the other end. Okay, so we're going to try to figure out which situation it is. And to answer that question, we have to understand what's going on with the p orbitals on the carbons that are doubly bonded to each other. And so this first carbon, we understand that these bond angles are 120 degrees, and that this is an sp2 hybridized carbon. So the 3 orbitals here that are participating in bonding are sp2 hybrid orbitals. That leaves one unhybridized p orbital, and it's sitting right here. And so I'm going to add in a p orbital. It's going in and out of the plane with respect to the rest of the structure. And in order for the pi bond to happen between these 2 carbon atoms, we have to have side-by-side or sideways overlap with an adjacent p orbital. So I'm going to add that p orbital in to the middle carbon. This is the pi bond. This overlap here results in a sigma bond. And so we have these two carbons now doubly bonded to each other. What I can't do with this structure is rotate about this sigma bond, for that would break this overlap, and it would break the pi bond. Okay? So these 2 orbitals need to stay parallel to each other. So I'm going to move on to the next carbon, and we see that these last 2 carbons are also doubly bonded to each other. And so that means that we have a sigma bond, and we have to have another p orbital on this central carbon. That makes this central carbon sp hybridized. There are 2 sp hybrid orbitals that are participating in sigma bond formation, resulting in a 180 degree bond angle here. Okay? So we see that we have this p orbital, now that I've just added in, sideways overlapping with the p orbital on the last carbon. And again, I can't disrupt that, or I break the double bond that is between these 2 carbons. Take a look at the last carbon. It, like the first one, is sp2 hybridized. So these bond angles are 120 degrees, and we have 1 p orbital that is, again, participating in double bond formation with the adjacent carbon. So this is what the structure looks like from beginning to end, and I can't rotate about the sigma bonds again. So once it's built properly from one end to the other, we can see that the hydrogens on one end are indeed not coplanar with the hydrogens on the other end.